So the whole point of the citric acid cycle, what we did just before this, right, was to take that 6-carbon chain that we made, and as you kick off the carbons, you make carbon dioxide, right? That's what we said in the other one. And then we liberated a whole bunch of hydrogens, which we tacked onto NAD and FAD. Is that right? Yes, of course it is. So then we want to take all those H's now and we're going to put them to work. That's the whole point of the electron transport chain, is to do something with the H's. So all the NAD H plus H's, they're going to go right here to FMN. He probably doesn't want you to know the real names for it. You can probably say the first coenzyme and that'll be okay. But NADH plus H goes to the first coenzyme. FADH2 can only go to the second coenzyme because it's like a lock and key thing. That's only where they fit. Okay. Both of them get stripped. The hydrogens are going to get pumped into the coenzyme and get stripped of the electrons. Okay. So electrons are now hanging out in here in my little bubbles. Okay. So the bubbles hold on to the electrons and then pump the protons through. Does that make sense? Yes. Okay. Because if you take away an electron from hydrogen, you only have one proton left, right? Because you have no neutrons. Right. Okay. So the protons that we have left get pumped up. We keep the electrons here. Do the same thing with FADH2. Okay. Now we establish something called a proton gradient. So you're going to have a ton of protons by the time all is said and done. You're going to have a ton of positive charge up here. Okay. We're going to use, because now it's just sitting there as potential energy. It's not doing anything yet. Okay. In the meanwhile, electrons that are in the bubbles are going to get passed along. As they get passed along, they're going to lose energy. It was their energy in the first place that got the protons pumped across, because we use the energy from the electrons to pump them over. And now we're going to move them this way, and they're going to lose energy as they come down the little jelly bean chain that it looks like. Whenever it gets to the end of the chain right here, at this last set of cytochromes, the electrons come down and bind with oxygen that's waiting in the mitochondrial matrix. Does that make sense? Yes. Okay. Now for the protons. So the protons are up here. They're potential energy. Now, the way that I read it in one book is they kind of describe the protons coming back into the mitochondrial matrix, this area down here, kind of like water going through a dam. You get a small leak, but it can power a whole lot of different things, if that makes sense. So the H is like the water coming through the dam. This is your dam. ATP synthase is going to act as your dam. All the protons are going to come through the hydrogen ion channel for ATP synthase, which is going to give us the power to make more ATP. So we're going to take some ADPs and latch on a P again, because we already have some P's floating around down here, and ADP as well, to make more ATP. Does that make sense? Okay. So after they've done that, they've given the power to do this, but now all those protons have to go somewhere. So they latch onto the same oxygen over here that all these electrons have latched onto, so that they can make water. Does that make sense? Is it more medium? Yeah? Okay. After all this is over, the end product, you should have 28 total ATPs from all the NADs and the FADs that you got from the citric acid cycle. And from the citric acid cycle, sorry. Should be 28 ATPs. For every NADH plus H that you put into the system, 6 hydrogens are pumped into the matrix, into the inner membrane space. 3 ATP are generated and 1 molecule of water. For every FADH2, you get 4 hydrogens, 2 ATPs, and 1 molecule of water.
Well, it's like the abdomen, but it's
so that's the general layer.
That's it?
Because if you come here, there's actually 3 layers here.
Well, man, we still have how many more ATPs to get our 36?
Okay, so let's think about it. You have 28 from here, from the electron transport chain only.
Oh, then we got them from the other two.
Right, and so you got 2 from glycolysis, so that gives us 30. Then you have 2 more from the citric acid cycle. That brings us to 32. We're missing 4.
Oh, from the one group.
So this is the weird part. So the 4 part, remember back whenever we did the first round of glycolysis and you had some NADH get kicked off? You're going to use that, and it's going to have to get plugged in all the way over here. But what's weird is he said to kind of think of it like coming into the mitochondria costs you some energy. But what really happens is that the NADH comes in from outside the mitochondria and plugs into the same place that this guy did. Because somehow it gets altered and it doesn't fit here anymore. So now it has to go to the next one, so now this one's rules apply. So it's only going to make 4 instead of 6 like it would before.
The transverse abdominis.
I don't think it's gonna be that deep, but, no, it should have been,
I'm just going to make 2 instead of 3.
yeah, exactly.